Hello, welcome back to our acid-base equilibria series, and this is part 5. So we're going to look real quick at what a Lewis acid base is. So between the three theories, the Arhenius model, focused on what ions end up in solution. Right, hydrogen ions for acids and hydroxide ions for bases. The Bronsted Lowry focused on which one accepts a proton and which one transfers a proton. So an acid is something that donates a proton, and a base is something that takes it. The Lewis concept talks about pairs of electrons. So the idea is that one transfers a pair of electrons, or one sort of donates a pair of electrons, and that would be a base. So a base is an electron donor, and an acid is an electron acceptor. So let's take a look at this example right here. If we have aluminum, and oftentimes our high energy or highly charged metal cations are going to become Lewis acids, because they do this in solution. And so within the Lewis model, it's difficult to explain it any other way except for the Lewis model. So if we look at aluminum, so aluminum in solution is actually going to create an acidic solution, because here's what's going to happen. The aluminum is going to go in, and it's going to make some of these aluminum hydroxide ions in solution. And so you can imagine that if it's combining with these and taking two hydroxides, you end up with free hydrogen ions. You end up with an acidic solution. And so let's look at this right here. So here's the aluminum, and if we were to to look at the aluminum has a pair. What the aluminum does is it gives, or it takes a pair of electrons from the oxygen right here, and so there you go. And let's look at some more examples as we go through. So this is BF3, boron with 3 fluorines, and it's going to combine with ammonia gas. Okay, so these two gases right here, and they make this right here. So the question is, which one of these is going to be the Lewis acid, and which one of these is going to be the Lewis base? To make this resulting product right here. Okay, so let's take a look. So BF3, when you do this and you make its little Lewis dot structure, what we find is that it doesn't have a full octet. It's actually only got 6 around the boron, and each of these each of these fluorines end up with 8, of course. So this is kind of one of those exceptions to the octet rule. So it doesn't have its full 8. But NH3, it kind of looks like this. We have 3 hydrogen connected to it, and it's got these 2 electrons right here. So when these guys get together, here's what happens. This ends up connecting over here, and the boron finally gets its 2 electrons that it's missing out on. And so let's go ahead and then look at it. So which one is going to be the Lewis acid? Which one's going to be the Lewis base? Remember, the Lewis acid is the electron pair acceptor, which clearly this would do. So Lewis acid is BF3, and the Lewis base is going to be electron donor. So here's the Lewis base right here, because it clearly is going to give the pair of electrons to the BF3. Let's look at one more example to try to help with continuity on this right here. And now we know that ammonia in water is basic. It creates hydroxide ions. So let's just kind of look at this in the sense of all 3 models. So if we look at this in the Arhenius model, there's our hydrogen ions, and our hydroxide ions. Sorry, hydroxide ions are bases according to the Arhenius model, and so this is basic. Okay? According to the Bronsted Lowry, a base is something that will take protons, and so this has gone from NH3 to NH4, so this has accepted a proton, it's taken a proton, so it's a Bronsted Lowry base. And then in the case of the Arhenius model, it's not quite as easy to see with this, so we'll draw it a little bit different, but if you had that original NH3, okay, remember the NH3 looks like this, and now a hydrogen comes up, a hydrogen over here comes up, and it's going to share over here with these with this extra electron pair right here and become that NH4 molecule. So the hydrogen is taking the electrons, and the NH4 then, or the NH3 then, is donating the electrons to the hydrogen. So it's a Lewis base. So in this particular equation right here, we can see or sort of interpret it from all three models. Arhenius, because we got the hydroxide; Bronsted Lowry, because this accepted a proton; and the Lewis base, because it donated electrons. So that sort of covers that, and hopefully that gives you a good explanation of what a Lewis acid base is, and also in comparison and contrast with Bronsted Lowry and Arrhenius.